How's it going, everyone? Welcome to another video on enterprise UI development, and today we're gonna get our hands dirty, have a more hands-on approach on how can we build now these GitHub Actions, understand and be able to describe the anatomy of these GitHub Actions, as well as what is the goal of knowing and building these GitHub Actions. So this will be a very interesting video, because as a way to connect everything in one sentence, or as much to condense as much as possible, it is important to also have a little bit of history, to recap that, to understand how do we get here, how do we get to the GitHub Actions, and then how that impact on this UI development, enterprise UI development. So this is a course taught by Steve Kinney, head front-end engineer at Temporal, right? Where the entire goal of this course is to look at how you can maintain large code bases over a long period of time with a wide range of contributors in large teams. So because of that, and the end goal here is to look at how you can maintain your applications, software. And because unlike your bike, your oven, fridge, mobile, even yourself, when you want to hit the gym or want to see yourself fit, or want to eat healthy, each one of them has a specific way of doing things to maintain that, right? So it's not the same that you, for example, you want to maintain a health body, or you want to maintain your physical health, all right? There are certain things or certain system that you must follow, certain practice and behaviors that you must follow as a way to guarantee the outcomes. So pretty much here on the maintenance on large code bases, where we're gonna see what are the infrastructure needed that allows to do that. So this infrastructure, which is the basics, installations of operations to guarantee, in our case, maintainability for its economy, for its judicious use of resource. Now we're going to see what are those components, what are those things that we need to, according to Steve Kinney, which is the component of a well architecture UI. So you need to have is a testing system, as well as a build system, also a static analysis that is able to check your code statically using TypeScript. Interesting. Is that charging? Why is not? Because it's about to die. There you go. Alright. Much better. Okay. Yeah, that was interesting. And also we need to look at the separation of concern, especially when you're building this user interface, the user interface logic and the business logic, right? And also the infrastructure for deployment. Hey, you're gonna deploy this code using CDN, Content Delivery Network, and what is the design process? Are we throwing everything? Are we throwing spaghetti on the wall, or we are now thinking in terms of how we're going to integrate code, how we're going to migrate, how we're going to change code, and all of this components is based on what are the things that make a code scalable, and that is, well, in this case, maintainable. And that is that we have the ability to add code, change it, migrate, and update its dependency without the feel or the fear of breaking something. So because of that, some of these ingredients of sustainability and maintainability, according to Steve Kinney, It is based on the pyramid of needs, which is the Maslow pyramid, as a way to say, hey, for your code, at least based on his experience, for your code, you will need to have the basics first. You will need to have the infrastructure for your testing, as well as your build system and the static analysis, and then you're starting to go up on top of this sustainability pyramid or sustainability architecture, right? The ingredients here, which means that once you define how you're going to build your foundation, how this infrastructure, then it is time to think in terms of the process. What are the process that allows to guarantee is the basis, and then we're starting to worry about other things. So for example, the process of, okay, how can we now make sure that our code is maintainable for code and review? No one loves code and review because it's involving a lot of context. It requires that the software developer actually burden or understand now what are the things that they do. Okay, so junior developers actually are not able to provide that kind of value. You can also use tools, for example, like Code, like Cursor, that allow you to provide as much as context as possible. Okay, so yeah, so you got this. Another process is, all right, how can we design, or what are the blueprints needed here, especially when you are going to add some code or change it, and not to mention that what is the design documents, all right? So how are going to make sure that these particular things work? So we need to have some sort of documents or sort of process that we know what is doing at each step. So for example, to define some sort of UI process and that kind of thing, right? Again, this is in the ideal world, because the further you go up to, the more time consuming can be, and therefore more money. But luckily for us, we can actually do that very simple, fairly quickly, all right, by looking at all of the things that we're gonna learn. And then we have the pattern. So this is recurring things that we need to do, and then we come up with some sort of solutions. So typical problems or typical solutions to common problems. For example, hey, when we need to actually is lay out the architecture of our application, okay? We follow the MVC, where we saw the MVVC, you know, the architecture, as well as when we need to manage the state of our application in the UI. Well, for example, state management. Abstraction is that, hey, is this particular block should not be aware of this block, and we can make it easy to test. So this is couple things that happen recurrently. In any case, here in this course or in this today's video, we're gonna see what are the tools that we're gonna use, as well as the unit testing. Make a quick recap of that as much as possible, because what we care in today's video is to look now at the GitHub Actions, describe the anatomy, and also see how we can actually create our own, which is not as wild, but understand is the anatomy of the GitHub Actions, be able to describe what is doing behind the scenes, which is something that if you follow with me along, we will be able to now articulate this, which is something that software engineer needs to do. You know, it's okay to have this hard skill, but also you need to have your soft skill, which is crucial, especially in this today world, that how you can make all of this abstraction meaningful to other is one of the role of senior developers. And in my case, and in my opinion, is also the role of any senior citizens. All right. So the tool here is React, TypeScript, Vite, VTest specifically, testing library, and Playwright. We're gonna have a more hands-on approach. First, we're starting with the testing. I'm gonna make a brief recap of this. So we have unit testing, component testing, integration testing, and E2E. The further are on the E2E, the more expensive it is because you don't own some of the infrastructure along the way. The further you go to unit testing is much more cheaper because you are now testing the language. And then some jargon as a way to make ourselves familiar with this, like an assertion, testing, and test suite. And this particularly description is when we're going to write our tests, unit tests. It's important to understand that here we're going to use Vite, which is make Jest migration easy, because after all, behind the scenes is using Jest syntax. Also, it is much faster than Jest because it's now reading in Go using ESBuild, which is ESBuild is the model bundler that is reading in Go, so it's much more faster than JavaScript bundles. It is ESM compatible, and as well as the ability to provide better error reports, switch easily between browser environments, and it provides now a flexible configuration as well. So we look now, one of the things, especially when we need to write our tests, we need to, because after all, we're gonna see if the function is returning something, if we're getting the outcomes that we want, which means equality. So we look at the greatest hits of the testing. So for example, 2B, which is compared using a referential equality, the to equal, which is doing a value equality, a deep nested value equality, the to be close to for floating points equality, the to be instance to check if this object proto has a reference along the proto I changed to the function constructor. You have to contain if this element actually belongs to this collection of values. To throw, useful when you want to run your functions. To match, to check if this string belongs to a bigger string. To match object, to spec any, to only check the type. And one of the things that we need to understand, which is very helpful, for example, expect object containing, which means that if you have a huge object and you want to only check a subset of property, you can do that with this. This is very, very, very interesting. So with that, all right, now that we look at part of the anatomy of how we can write our tests, as well as what are the things that we need to write our tests, we also look at the way of how to do that by defining is the setup, then the testing logic, and ultimately the assertion, only one assertion per test. Some of the advanced techniques that we can do, especially as we are handling is now async or tests. All right, so you have now techniques like async and await, or another technique like reject or resolve, right? And some tip, especially when you need to handle is when you need to write bug fix. Okay, you take the ticket, you take the problematic code, and then you write a failing test to make that happen, to make it pass. And when you need to also handle is UI elements that appear at some period of time and then vanish. This is when, for example, thumbs comes here in place. And this is a particular pattern that what it does is to see, hey, I want to make this value time, I want to make a value, or this is making a time independent wrapper around a value, right? By using closures. So again, this is quite some of the things that we can do, especially when we're handling this advanced topic. Okay, and finally, the GitHub action, which is one of the things that allow us to, after we write our tests, we see the advanced techniques, we are now in our first forage to set up the build tools that allow us to run the affirmation test to check if everything works as expected on this CI/CD process, or on this servers, GitHub Actions that actually provide for us. So CI/CD is just sits between the automation process between all of these engineering fields, especially on the UI and the backend, where the whole point of this is to automate the co-integrations, deployment, and delivery, right? So here you have now is the anatomy, the end goal of these GitHub Actions, which is, remember, make the integration, the deployment, the delivery streamlined as possible, right? So here there are several things that we do in each one of those phases. So we first start with plan and then code. Once we do that, we create a PR to actually on this system is going to build our code, test that, and create now an artifact of this new version, of these new changes that we did. And then it's going to be passed to the continuous delivery, which is you put that on the staging, this environment close to productions, to see if everything works as expected before deploying that code. And then once you do that, now you need to operate on that, so wait to see if everything works, and then monitoring that. So this particular process that I'm describing here is something that we are going to do every single time, especially when we want to maintain our code, right? If we want to add something, or if we want to change or update our dependency or migrate our code or do a refactor, this is the particular process that we are doing here, as a way to make this co-integrations and delivery with large teams much more faster. And we don't have to rely on this manual review as much as possible. Again, you're gonna do at some points and some particular phases, okay? But it's much more we as human people are more willing to not do anything or convince others to somebody to cut them some slack than the turn off the build process. So these GitHub Actions, okay, now that I know the anatomy here, especially the CI/CD and the usefulness or the use case of the GitHub action, is that, well, for example, if you have a SaaS and an open source, it is great because if you bump up ANPM versions of your open source, you can have a workflow that actually automatically bump up the version on the cloud. So instead of actually you creating up here with the change and then pass through a code review process and then merge those chains and ultimately now have to publish that, all of this has been done for you. This is one of the ways how you can automate a process specifically for big companies that they want to actually create these open source tools. Useful, for example, for eBay, right? That when they have now this markup this user interface framework. All right, the React is another good example. TensorFlow, PyTorch from Facebook, as well as from the goal of PayPal, right? But this is one of the useful use cases, and the other is the ability to automatically build and test your applications, deploy your applications every time a new release is created, or create a label when a new issue is open. Again, describing the most common use case, because now this is where you're gonna get the most value out of this. Okay, if you want to go into your own adventures to see how you can actually automate all the process, you can go. You're free to go. You're free to choose your own adventures. But in the context of enterprise, this is the main use case, right? You have a SaaS, you have an open source code, great for bump up the NPM versions, right? Also for automating the build and test your code on every PR. So deploying your code, or deploying the applications every time a production release is created, okay? Or yeah, when a release is created, that's something useful, okay? And also is adding this new label when a PR is created. So now we need to look at what is the anatomy of this GitHub action. So we look at what is the CI/CD, what is the value proposition of CI/CD, as well as how can we. So what is the main use case of doing that in GitHub, and what is the anatomy of that? So. First, we have now the workflows, which is something that you define under the GitHub/workflows in plural. I learned that the hard way yesterday. Okay. Anything here that you're going to define is your jobs. It can run one or multiple jobs, and you can also reference workflows as a way to reuse it. This jobs runs, this jobs has a set of steps. So for example, let me actually be more here. Yes. So you can see what I'm doing. No. Okay. That's right. So this is the workflow, right? The way of how you can create this CI/CD process in GitHub Action or in GitHub, right? So the anatomy of this workflow is that, this is the workflow where you can define one or multiple jobs, and those jobs, okay, have now a series of steps that are running on a single. Or that are executing on the same. So this series of steps, they are now run on the same runner. So this series of steps are bash script, in this case, like this. So this series of steps are bash script or GitHub Actions, okay, which are custom applications where we can now custom apps from the GitHub Actions marketplace for frequently repeated tasks. So for example, like clone a repo, or define a build tool change for setting your application. So for example, in this case, this is the build tool change. For example, in this case, we want is to now run is Node, okay? So once we create this repo. So when we clone the repo, we want to now install all the build tool chains needed for. Luckily for us, only Node. And they have this particular version as a way to describe is what are the new changes that they apply, some security bug fix, and that kind of thing. So yeah, all right. And this jobs, okay, or these steps happens is sequentially, one next to another, all right. And since these steps are shared on the same runner, you can share data across these steps. Remember, after all, these steps are just bash scripts, right? That are now executed on the same runner. By default, the jobs are running in parallel, so you can actually make one job depending on another. Okay. In these runners, which is something that they don't define here, okay, which the runners, which is now a server that the runner is now, so the runners are a server or a process that provide you GitHub, so you can run is one job at a time. It's important this. You can run a single job at a time per runner, okay? And this GitHub Actions or this, so Git provide you this process or this service where you can now run is a job on each runner, on each of this instance they provide you, you can run one single test, one single job that of course it'll be triggered by one of these events that can be GitHub Actions that the definitions or schedules or posting to REST API as a way to now trigger some webhooks, for example. So this is quite interesting. This is very, very interesting because one of the things that we can have here, or the key value of this, is that isolation, all right, and parallelization of these jobs. We have also granularity by these steps that allow us to do that, and we can also reuse that by creating its actions, and it is flexible because this workflow can be adapted to various triggers and tasks. So you don't only have a particular workflow that works for a single event, but it can be reused for others events. So one of the tips here is that, and now I want to actually show what we did yesterday, which is GitHub Action. I think it's this. Yeah, is this one? Yes. No, I mean is this action workflow, adding URL proper here. Let me take a look at this. Oh, that's interesting. Why not able to see this? Well, it's very, very interesting. Action workflow tests. It's this one. Oh, okay, it's this one, exactly. Action workflow tests. So as you can see here, we add in some of these tests, okay, followed by fixed typo, which is something that bite me. yeah, I changed the plural here, so yes, and it actually run as expected our test, right? If you wanna take a dive deep into this, how many time it takes, it's actually quite fast, 32 seconds. This is the workflow that it's doing. It's very straightforward and simple, and you can get as much complicated as you want. But the whole point of this is to understand is this, as well as their main use cases. So, good, great. Let's get into this.
I really like the GitHub, maybe. PRs of choices, I can literally, and that's an exit one, which is like not intentional. Fleet has picked it up yet. That we'll have to do is like kick something off and start talking, take a lucky guess where we're going with this.
Yeah, in this case, when we look at the summary, it actually defines all of this series of jobs here, as you can see here, where in this case we are only running is one jobs. That's why you see this kind of thing. You can actually go into this and understand that the following action use a deprecated Node.js version and will be forced to run Node 20. Action checkout version 3, action setup Node version 3. It actually gives you some of the things. This is also especially, again, very specific for people that actually are now able to define those kind of things. Okay. Or they need to work closer to that. All right.
You might have seen, and I can merge it in. Now, there are some things that we might choose to do here, but that was our very first run your unit test GitHub action. Not that hard.
Yep. Mm-hmm. 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 Let me close this. Our first GitHub action workflow. There you go. All right, next one is the build step and branch protection.
Now, GitHub Actions are super powerful. You can do all sorts of crazy stuff like we talked about, but the very first one is super easy. Now, to our point that like we can write so many less tests now that we have TypeScript. It would be nice to have TypeScript validate that things were okay too. The easiest way to do that for most setups these days is to just run the build process. Well, that must be why he called it build and test. And so like we can basically try to add another step to this script, right, that also tries to build the application. That will expose any kind of like TypeScript issues as well, and will allow us to try to add another step to this script, right, that also tries to build the application. That will expose any kind of like TypeScript issues as well, and will allow us to see that as well. And so we want to just add another run command to not only do npm test, but then also do like a npm run build. And get that process going as well. So why don't you add that in, and then we'll take a look and we'll see it all together, because I'll do it too and kick it off, and then we'll view it and like play around with it a little bit as well.
Okay. Just this. What is npm CI? Is a variation that is making clean update. So it insists you to already have a packet log JSON. It will error out instead of updating packet log JSON if something doesn't match. It installs all the dependency. It as you can just use to install one dependency like npm CI, testing library React, or something. It blows away no model if present, and it doesn't write two packages. So exercise, add a build step. Right now, build and test, only test. Add a step that runs npm run build to the action, okay? And bonus, add a name to the step where we check our repository and run npm build in parallel with npm test. That's also interesting. So when we talk about parallel, all right, we say, okay, we need to actually create another job here. That's one way we can do this, all right? We can say, hey, again, following is this recommendation. It's like, hey, I want you to run this in parallel with npm test. So because of that, if we would take a look at, if we go back to our workflow here, we can say is, hey, instead of build and test, you say, what the French does? You can say is now, right now, build and test only tests. Add a step that runs build to the actions and add a, exactly, it's going to add a step. Oh, this is quite interesting, because it say, hey, let's going to now run this as a step, not as another job, but as a step. Add a name step where we check our repository, and when you want to run in parallel step workflow here, because by default GitHub Actions. There you go. Because by default this workflow syntax. Jobs and steps. Okay, steps like this. A job containing a sequence of tasks called step. Okay, in plural. Okay, step can run commands, run set of tasks, or run actions in your repository. A public repo. But I wanted to take a look first is this. On the steps, because it says that steps are executing in order and depending on each other. Since each step is executing on the same runner, can share data, but it tells that steps are executing in order. You know? Or run an action into a repository, a public repo, or an action published in a Docker registry. Exactly. Step can run commands, run bash script, run setup task, or run action in your repo, a public repo, or any or an action published to a Docker register. Not all steps run actions, but all actions run step. Exactly. So not all steps runs actions, but all actions run steps. These bash scripts, these repeated tests. Each step runs in its own process in the runner environment and has access to the workspace and file systems. Because steps run in their own process, changes to the environment variable are not preserved between steps. Because each step runs in its own process in the running environment and has access to the workspace and file system. So this run, okay, it has now its own process inside of the runner, inside of this virtual machine that is provided for us. Because a step run in their own process, changes to environment variables are not preserved between the steps. GitHub provides build step to set up and complete a job. This is interesting. So, because now this runner, which is this server that are given to us by GitHub, where it provides now a new fresh provision virtual machine, whether it's a Windows, Ubuntu, or Mac OS, where each runner can only run one job. Okay, and inside of this job you can have as many steps as possible, or as many bash script as possible, and each step is now running in its own process in the runner. Makes sense, okay? So they can share data across that. Okay. GitHub's only display at first 1,000 checks. However, you can run an unlimited number of steps as long as you within the workflow user limit billing and administration for GitHub hosted runner and about self-hosted runners to self-hosted. Okay, now this is when things started to get interesting. As you can see, okay, uses run working shell with arguments and env. Interesting. Runs command line programs that do not exceed 21,000k characters using the operating system shell. If you don't provide a name, the same will be default to the text specified in npm in run command. A multi-line command. Each run key represents a new process and shell in the runner environment. When you provide multiple lines, each line in the same shell. So what it is, okay. So now that we have this notion, we want to do is this: npm run build in parallel npm test. Okay, so perplexity here. So how can we write steps in GitHub workflow that runs in parallel? For example, npm run build and test, right? You have the build and you have the test. Oh, but this is steps here. Okay, this is, exactly, because after all, jobs runs in parallel, not steps. This is, you can do that to check if the build process, this is where you can check the tests as well as the deploy, and now you can make these jobs to be dependent on the build and test. So in theory, okay, if we want to run now tests in parallel, we can say is, follow me along with this. You can say, hey, this is now, wait, what? This is now the build. Well, we can actually make this the test. Okay. We can also define another job here to say build, that is gonna runs on. This is what you define is the what are the OS that this virtual machine or this runner is gonna runs on, and then the series of steps, okay, where you can put this name. Well, of course, you need to define your actions as a way to check out that. Oh, give me a second here. Oh my God! All right, back to business. Back to business. Back to business. Woo. Mother Nature called me. That's what happened. Well, in any case. So yeah, here we are creating is this series of basic stuff as a way to set up is the on this runner, because remember, after all, jobs are run in parallel, and each runner can and each runner can execute. Okay, and each runner can run a single job, which is this. So each runner, this provision, this newly fresh provision VN by GitHub runs on one job. So here we're doing is this: a build runs on the step. I want to now clone this and then provide now a name for the next stack, which is setup node. Okay. Setup node, and then use this action, which is this bash script for repeated tasks as a way to install a node. We can go that deep of what it's doing. We can say, hey, with no, we can specify here the version that we want to run this, 20.10.0, right? Okay, and then we want to now is run this. Specify is the run, which is, hey, once you now define the setup, it is time for us to not only install the dependency, but now is run the build, right? You say, hey, install the dependencies, okay, and this is now using the command run. Say npm ci clean install, right? And then define another. Once you are done, define another test here, or another step. When you say, hey, run build, run. This is bash script that I want to do. npm run build. Pretty straightforward. Right? So let me actually see if that's what Steve Keeney did.
So the workflow that we had before, called build and test, but it only tested. So our mission was to also make it build. And there's a challenge mode here, which is like a segue into the next thing we talk about. But let's just deal with the major piece there, which is also build. Now, if you're using my repo and it's live, there was like one issue with a type alias that stopped it from building, which is great because now I can show you kind of the good and bad. So this is our first one where we had that npm test script that exited with a 1. Then we fixed it, and then like the build did legit fail. So you can kind of see a few things, right? Which is, one, it fails, and you can click in here. This is in the Actions tab. You can also get to it from the PR. Where you can see like, okay, here's like where it blew up. You can see all the test stuff as well, but that all passed, so nothing to look at there. But with the npm run build, you can see that it did blow up. And the kind of cool thing that it will do as well is, where did it go? Oh, here it is. The annotations. And you might have to do some configuration, but what's really cool with this is if there are lint warnings now, I'll also see that here as well. It will like annotate the PR with like, yo, this didn't break the build, but like, you got a little silly thing here, right? In this case, it's just showing you like, because if you think a lot of these stack traces have the file name and have the line numbers and stuff like that, so it is able to kind of like show you, and complete with error code of 2. And so I fixed those, and then I added them to the commit. So we go back to actions, and you can see that it passes at this point. right? You get a sense of like what branch it was on, so on and so forth. You can filter. In this case, we're only doing it on pull request. You can hear all the.
Okay, so let me instead actually see if from here, if it's actually match this GitHub action here. What? First action, removing verbose. What the French does this? Oh. All workflows, but I think this is something. Exactly. I'm not sure that I can see that in fact. Our very first GitHub actions. Build and test expected. Hyphen check. Learn CI/CD to this. Not quite sure if I can. These merge commits were added into this branch cleanly. Update test script in package.json. Oh, of course. And then you take a look at the unit, update the unit tests. So he run that there, so he didn't change that. Okay. All right. Okay. So by doing that, right? So by doing that, in your workflow, all right? This is if you want to multi-line. The step will default to the text specified in the run. Command run single using non-login shell by default. You can choose a different shell to customize the shell used to run command. For more info, that each run key will represent a new process and shell in the runner environment. When you provide multiple lines, each line run in the same shell. Okay, each run key will represent a new process and shell in the runner. Okay, so you are now using this virtual machine that is going to provide you as the resource where you can now is run multiple steps here or bash script like this. Okay. So instead of actually us to create now a new virtual machine, which is gonna what will happen if we create another job, we can only say, hey, you know what? Let's make this simple. And I want now to here not only run is this. Okay, I want you to not only run this test, but in parallel, I want you to also run, or in another shell in this virtual machine, I want you to run is the build. Makes sense. Makes a ton of sense. All right. Okay. Cool. Oh. So we are using is now the resource of this particular virtual machine, aka runner, where we can now run is several bash script that is providing us. We can run is several bash script, which is created is several process per this virtual machine instance.
Different statuses. And I will show you some of the events you can watch for in a little bit as well. The branch and the actor, there is one. It is me. Cool. So here you can see that in this case it went successfully, which means now I know that, hey, this builds before I merge it into main, and all the tests pass, right? Like, great. Now nobody has to run it manually or anything along those lines. We now know with confidence that theoretically you can't merge bad code into main.
Exactly. theoretically you can merge bad code in.
The word theoretically is doing all the work in this sense because I totally can. Right. In fact, there are no rules in this repo. I can do whatever I want. And as an admin, you can always kind of do whatever you want. But like, this is why like most companies have like principal police access, which is like at most decent sized companies.
Yeah, this is why most companies actually have this principle of least privileges. Like, hey,
not even anyone on your team has admin access to your own repo, right? And it's to stop you from doing things like this. Because in a lot of cases, there are rules around things you need to do to be compliant to. Its name is SOC 2. Is that the one?
Yeah. SOC 2. System and organization control. We need to be compliant of this. Oh, I get it. But this is based on the SOC. Okay. Audit. Love it, bro. Love it. You have to be compliant with SOC. What SOC stand for? What does it mean? SOC compliant, SOC 2 compliant. It's a security framework that specifies how organizations should protect customer data from unauthorized access, security incidents, and other vulnerabilities. Man, what the fuck? System and organizations control too. Security, availability, processing integrity, confidentiality, and privacy. It's a security compliance. It's a security compliance. Interesting. Very, very, very interesting. The security compliance. Okay. The security compliance.
Right, something Enron. So now that there are a lot of safeguards in place to make sure you can't do bad things. So how do we kind of set that up for ourselves? We can kind of go into the settings, and you can also get here. We'll see from the pull request too. Go to settings, I go to branches, and I have not protected any of my branches. Most importantly, the main one, the important one. So that's settings and branches, but also I'm pretty sure if you go into the PR, it will also say like, hey, you can have some rules here. Would you like to add a rule? It's very much like you should have some rules, which brings you to the same page, was one clicking on main. For most things with GitHub, actually I was gonna say GitHub, actually this is true for most things with GitHub. If it is open source, almost everything is free. If you would like to make stuff private, that's when there's some number of minutes that you get for free. It's somehow there's a lot of rules. I work at a SaaS company. I don't understand how pricing works even for the thing I work on, but I also work on open source projects. I don't care. So here, like we can do all this stuff, but if you did make this repo private and you don't see the ability to do all this stuff, like that's why. That's mostly why I mentioned it. So this is the main branch, and again, you can do
Exactly. So you have now all of these particular features that since Git provides. Free means that you're the developer. Free means that you're the developer. Anyway, branch protection rules, whether they define your GitHub free plans, can only enforce rules on its public repo.
Pattern matching here as well. Require pull request before merging means that like you can't push to main. This one's tricky when it's a repo with just you, but you're also an admin and you can bypass that rule anytime you want. So you can do that or do not do it, which is required.
Where enable pull request targeting a matching branch, require number of approval and no change request. Okay.
It's approvals.
Require approval.
Cool. All sorts of little rules. Like generally speaking, I'm not going to check most of these boxes because like I don't want to, because I'm one person demoing in front of people. But like you should probably check almost all of these boxes. This one's tricky because I tried this one time, and like I was like, oh, I want to have it like auto assign the most helpful person. Right, but it's like that person has to do it, and you know what you never want is the person who had like code over everything being me, and you never want like the manager to have to do every pull request review because he's in meetings, right, and he's not the best on that, right, and so I had to turn that off, and also we have people work in London, it's time zones, life is hard, but that one made.
Interesting. So require review from co-owners is like if you are a manager, most of the time you're not going to look at this.
Maybe not. And I'll talk about the co-owner stuff.
Worry about it.
For the require approvals one, is that anybody can approve it? Is there a way to set it up so?
Anyone, I believe, with this one has to be like with like right access to the repo, right? Mm-hmm. You can change the number too. Like I think they have to have right.
So anyone who can push.
Yep.
Okay.
Yeah, I don't think I could be wrong on that one because
it's like collaborator.
Yeah,
it's
collaborator.
It's a permission level.
It's not just a not a rando.
So is there a way to change that?
I don't think you can change the level.
That's just GitHub setting.
Yeah. Yep.
Okay.
Maybe with
you could use
enterprise.
co-owners. So like I'll kind of basically the high level. Yeah, it is path name, username, and it means that like if you are touching this file. Like this is really great for like a mono repo where you have different teams like contributing to the same repo, which is like somebody from this team has to be the one who approves it on their part of the code base, right? So you can get a little bit more granular with who can do it, not just anyone in the org or anyone as a collaborator. You can say like only the people who are in this file can do it. Yeah, which again, I'm on the full team is like 8 people. It was the 8 of us, right? So I try to get very specific. Oh, is it this file? I worked on this, so like I would like it to like auto assign me, but then like it couldn't like, and you can require review from the code owners. There's nuances here, but generally speaking, don't let people push to main without somebody else rubber stamping it. Require approvals. This is the one we care about though. Require status checks to pass before merge.
Okay.
Because what is the point of running the test suite if you're going to let people
require status check? And what does it mean the status check is?
People merge anyway if it fails. Because then you've just merged failing tests into main, and nobody likes the person
require status check to pass before merging.
who does that. This is the one we care about though. Require status checks to pass before merging. Because what is the point of running the test suite if you're going to let people merge anyway if it fails?
Oh my god. Require status check.
Because then you've just merged failing tests into main, and nobody likes the person who does that. And this one makes sure that like you've like rebased in main with that as well, like, and so that you're like you've got like the latest version of main that you're based off of. It's not like an old version, so on and so forth. Cool. And like you can pick which checks. And hypothetically, yep, I have one, which is build and test, which is run by GitHub Actions. And that will say that like, cool, before you can merge into main, this check has to pass, right? Now, admins, like not just collaborators, admins can always override this. And like, since this is a personal repo, I'm setting up a lot of rules that don't apply to me. As the only person who can collaborate with this repo. There's some other ones in here.
Okay.
Admins, like not just collaborators, admins can always override this. And like, cool, before you can merge into main, this check has to pass. Right now, admins, like not just collaborators, admins can always override this. And like, since this is a personal repo, I'm setting up a lot of rules that don't apply to me. As the only person who can collaborate with this repo. There's some other ones in here, and these are again, these fall like when we talked about that like systems process and then patterns. This comes down to a lot more of the process piece. Like whether or not you choose to use code owners or something like that is like a process. This one, like if you've seen like comment like systems, process, and then patterns, this comes down to a lot more of the process piece. Like whether or not you choose to use code owners or something like that is like a process. This one, like if you've seen like comments can get resolved like in the threads, this is say like all comments need to have hit the resolve button. So you can't be like, you should change this, and then somebody else comes in and approves it, and then you just ignore that other person, right? You know, signed commits are like, you know, if you do it from the UI, they're signed, but like otherwise you need to get like a cert. Yeah, lots of like ways that you can tweak this. You know, every box you check adds safety, except for the lock branch, which just makes it, I guess lock branch makes it really safe, right? Because it means it can't change. Oh yeah, this one.
Local branch is read only. Users cannot push the branch. Yeah, okay.
These are like, you know, if you do it from the UI, they're signed, but like otherwise you need to get like a cert. Ignore that other person, right? You know, signed commits are like, you know, if you do it from the UI, they're signed, but like otherwise you need to get like a cert. Yeah, lots of like ways that you can tweak this. You know, every box you check adds safety, except for the lock branch, which just makes it, I guess lock branch makes it really safe, right? Because it means it can't change. Oh yeah, this one actually will stop you from being able to break your own rules. But then you
Do not allow bypassing the above setting.
you can also turn it off as an admin. So yes, you can lock the door that you have the key to. You know, and so you can, you know, obviously every box you check adds a certain level of safety and a certain amount of hassle, right? And so this is that process piece of like, how do you manage a team, managing a code base, both either as a member of the team or the leader of the team. It's like figuring out what the what level you're comfortable with. Now, to be clear, it is very tempting to be like all New Year's Eve about this, or New Year's Day, which is, it's a new era of quality in our code base, and check every single box and put on draconian, and it's a great way to have a small scale revolution on your team. It is like the natural inclination. It's like, I found out about these features, we're gonna have the best process ever, I'm gonna make everything safe, and then like there will be riots and, like in your team. So my suggestion that you didn't ask for is, you know, the obvious ones of like, make sure the checks pass. Like, I think everyone can be on the same page with it's like, don't merge failing tests or a broken build. That one seems non-controversial to me, right?
Yeah. It's like
I'm gonna make everything safe, and then like there will be riots.
Make all of your tests passing.
So my
before merging to
suggestion
me.
that you didn't ask for is, you know, the obvious ones of like, make sure the checks pass. Like, I think everyone can be on the same page with it's like, don't merge failing tests or a broken build.
Yeah, don't merge failing tests or a broken builder. Don't merge failing tests or a broken builder. Yeah.
That one seems non-controversial to me, right? Somebody should review this PR before I just open it and merge it myself. Seems non-controversial to me. If we want later, I can pull up my own repo and see which ones like. Some of them have been checked and then unchecked by people on my team. Right, and so we can see what the current state of the world is if somebody's interested in a little bit. Cool, and then like you can see like I can turn off the ability of what I just did earlier, which is like force push. Like again, like sometimes you need these things. But I would start small and build it up and create this. Cool, so now I've got these branch protection rules in place. And
Okay. All right. Let's go to talk about branch protections here. So this is build step in branch protection. So branch protection. So build step in branch protection. Okay. Where the whole point of this, okay, TLDR, start small, and then you can, start small. Okay, some of the anatomy of branch protection. Right. So the anatomy of branch protection is something that we're about to see here. Even though they tell you, hey, you know what? It'll be nice to actually put some rules. Let me do this. In this particular branch, you tell me, hey, it would be nice to actually put some rules to this, which is great. Okay, and then you define is your rule set. Interesting. So branch protection. This is the rule set.
Now, if you do it for care about though, and you don't see the ability.
But instead of rule set, it puts this now on branches. Oh, it's because now they change this kind of thing. Okay. Classic branch protection have not been configured. Define branch rules disable first push, prevent branch from being deleted, or require pull requests before merging. Learn more about the repository rules and protected branch. And there you go. About branch protections and rules. Manage protected branch. Okay, about protected branch. Okay. But this is now from the repo. But this is now from the repositories. Okay. 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 Now it is more about take a look at the anatomy of the repository. Okay. Okay. Anatomy of repo. Repository. Start small. So before, so what we can do here is just add in this new run build here. That's what I'm gonna do here to add this. You say git log, git status, right? Say git add, or look at the diff here of the GitHub workflow unit test to see what's changed. All right. Run build. Interesting. Oh, I get it. You know what? Okay, and then unit test here, and you want to do is this, and also run in another script, in another process, in another shell. Do this npm test, npm build, and unit test. But on this, okay. Once you save this, you say, hey, git status, if you wanna, for real. That's right. Much better. And then you got is this. Say git status, or git add everything, git commit. Use F if you really want to add them. Git status, git add, git commit. This is interesting because it's also provide you some auto completion here. Interesting. Git commit with a message to say, hey, I'm going to manage this. Say add build step here. Then you say git push origin fork. We can say git push fork of this action workflow branch, right? Position. Oh, it's because it's tests. That's right. Now, there you got it. So we take a look now at the particular branch. Okay, which is after I add those changes here. When we go back to our own branch, where is it? I think it's this. No, it's not. Can we go back to our own branch here? Okay, let me take a look at my own fork, which is this. Okay, this one, this one. This was merged. I want to check is this, and now as you can see here, we add this build step, right? There you got it. That's all right. Cool. Now when we take a look at this and say, hey, workflow is not valid. Wrong is already defined. Okay. Here it tells me, hey, this is not. It's a run is already defined. Oh yeah, which means is so by looking at this particular change, okay, this is how I supposed to add this. Yeah, that's quite interesting. Of course, the CI/CD, bro, I break the CI/CD, which is not good. Yeah, which is not good. Yeah, definitely, that's not good. Okay, definitely it's not good. Definitely it's not good. And this one, interesting. Wrong npm run build. Oh, we're saying is workflow is not valid. Exactly. But it's run CI, run test, and run build. It's already defined in line 25. No, it's because I need to actually do the npm run build from that. Okay. Npm run build. Okay. So you say, hey, let's go to add this. Fix typo. Fix typo. Alright. And then you push that workflow action test to see if everything that works suspected. You go back, all right, to this one. Okay, fix typo like that. And if we take a look at the actions here, it's now 1 second. It's telling me the same thing. It says, hey, this is an invalid. Okay, it's already defined. So do I need to define another name like that? Can I? Okay. Name. This is run build and run. This is run test. Run unit test and run build. Okay. Makes sense. So if I say is there, add a name to build step, and then you push that little change to that. All right. Can we now see that in action? For example, here, action workflow test is now running as expected. Okay. Exactly. So now GitHub actually detect all of this. Is I say, okay, makes sense. Let me do the thing that I know that I have to do. Good. Cool. And as you can see, we are now being able to see that. All right. Okay. That's supposed to be fairly fast, right? It's gonna run one process is gonna run a unit test. That's what happened with this step. It's running one after another in this case. So when we run our tests, then we build that, which is good, and then the job is completed as is. This is supposed to run actions here. So all of this makes sense, especially if we're able to describe what's going on. So as part of protecting the routes here, which is this, these things change a little bit from the previous one. So now you can add some rule set, let's say protecting branch or branch protection. Okay. I think it's important to look at the anatomy of the repo here, repository terminology, as a way to make ourselves familiar with. Branch, a parallel version, clone, fork, merge, pull requests, remote, and upstream. About repository ownership, permission level for personal account repository role for an organization, and that kind of thing. About repository visibility, and next step. favor branching over forking. And there you go. Okay, so we are looking right now is at the about protected branch. Protected branch are available in public repo with GitHub free and GitHub free for organizations. So as you can see here, about protecting branch, about branch protection of all of this, that's quite interesting. Okay, you can create a branch protection rule in repo for a specific branch. All branches for any branch that match this, and automatically merging a pull request. Because that thing's
But
change.
also, I'm pretty sure. Actually, I was gonna say GitHub Actions. This is true for most things.
Exactly. Branch protection rules. The interface changed a little bit here. You say, hey, let me leave this. Add branch rule set. And they're going to go through this. Protect your most important branches. And add classic branch protection rules. So now this actually changed a little bit. Okay. So now this actually changed here. Branch name pattern, the same name. Require a pull request before merging. Okay. So the TLDR of all of this is require a pull request before merging. And the other is require status check to pass before merging. And this is status check is you say, hey, required no check has been added. That's right, because I need to merge those change. I need to merge those change. Build and test. Okay. Requires branch to be updated before merging. It's gonna depend of this, but this is more about is the process rather than the systems. The build test in GitHub Actions. That's right. You can take a look at what is the any source. No, the GitHub Actions. Require conversation, require signed commit, require linear history, prevent merge commit from being pushed to matching branch. Again, this is now part of the process of building this building so to provide security here, to provide security, branch security here. Okay, makes a lot of sense. Makes a ton of sense.
Things with GitHub. If it is
Okay. 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 Interesting. So at least here, all right, so at least here, or in this case, anatomy of a simple branch protection. Okay, so run test, exactly. Anatomy of a simple branch protection is that run this test. Okay, require pull request before merging. Is like make a peer before merging. Exactly, make a peer before merging. Especially to main. All right, make a peer before merging. You can also put some require approval, and then is require approval. Okay, and require status check to pass before, exactly, and require. So don't merge something. Don't merge something if it breaks. If it is a broken bill, or don't merge something if it is a broken bill, or don't merge something if it is a broken bill or a failing test. Or a fail. It's a broken or failed test. That makes a lot of sense, right? That makes ton of sense. Merge branch protection. Proof read the following sentence. Do you call sentence? Is there a broken bill or a failed test? Don't merge anything if it's a broken bill. Exactly. Don't merge anything, because we are denying that. Don't merge anything if it is a broken bill or a failed test. Again, anatomy of a simple branch protection. It is something like this, and that makes a lot of sense. Okay, and that makes a lot of sense. Require approvals, and the other is this one. But is this anatomy of a single branch protection? That's right. Okay, that'll be all for this video. Take care. Bye bye.